Okay, so now we are coming back for the final step for this week, and we are learning to do paired t test and JASP. So, paired t, unlike an independent sample, means the sample comes within the group. So, as you'll see in a minute, so here the thing we're looking at a pre-diet body mass versus the post-diet, body mass, and seeing if they, the groups lost different amounts of weight. So be comparing one to the other to see if there's a significant difference based on this treatment or diet group. So, and for paired T, rather than, like I said, the independent samples, you're comparing one mean versus the other to see if the groups are significantly different, or population is significantly different. Here, you're comparing. So you're comparing the difference of means with independent. Here you're comparing the means of the differences. So you're taking a difference for every sample. Then, or actually, let's see if I can find what I got here. Yep, that's not it. I'll show you. Here we go. So the file we're going to be looking at is parity, and that's that. If I can get it to open, I'll show you in Excel really quick what we're doing here. So if we wanted to do this in Excel, and we got the samples here, we could easily go to the data analysis tool pack here and scroll down, select paired two samples, and then look at sample one, and then, down to 79, sample two down to 79, click labels because we got labels there, hypothesize mean. So that's where you're allowed to do that in Excel, but not JASP. So I wish they would add some of those features, but it's okay. We're going to open a new worksheet. So that's going to give us our answers really quickly. So here we got the mean for first group, mean for the second group, the variances, observation for each. They have to be the same. You can't have any missings because it's comparing one to the other, kind of like a correlation. Like I said, it limits any outside interference. So it controls for everything because you got the same people at time one and time two. There's your T-stat, which is what we should get in a minute. And our two tail significance and one tail. So depending on whether you got forward or backward, it's going to be, whether it's positive or negative. Your critical T, which again, JASP doesn't give us critical values. That's where we have to get to the difference or the average, the difference of the averages or the averages of the differences have to get to be significant. So what does that mean? Let's go back. So if we were actually doing this, we would have a difference column or a D. So how you get this is equal this minus this and roll down. So now we're going to take, now we're going to take, equals average of all these and equals standard deviation sample for all these. And our sample size 79 because these are the same. These are same respondents. So that first week, the one with the birds or whatever with night owls, that's the one. It actually had a paired sample, and some of y'all caught on to the fact that it was one respondent, so you'll put half the the response size. I wasn't expecting you to do that, so I was counting each row. So good job. So here's our standard deviation variant. So if you're using this spreadsheet that I put up here, and you're welcome to, you just have to enable macros. And if you can't get them to enable, then you go into the folder, you got it, and right click and click on properties, and then it'll say enable somewhere on there. So you can enter that's the see, that's D bar. So that's the average distance. That's our test, 0. Number, sample size 78. Standard deviation 2.56. And whatever you want for your alpha. And again, there's our T value, which is pretty much the same as what we got over here, 13.05. Yeah, we got 13.04 there. Now we got 13.05, probably because I rounded off the variance. And P value far less than 0.001. And again, if we want greater than, we're going to be way over here. If we want less than, we're going to have pretty much the same results there. So that's how you'd use the paired T in here. And if you had independent samples and you wanted to actually use this, if you only had summary scores and not the actual data, the Z-test is up top, 2-tail, 1-tail, and it'll tell you your critical values and your degrees of freedom. It won't tell you your effect size. You're going to have to calculate those on your own. So Welch test is in orange, student T's in blue. One sample, so all of these are there. If you downloaded it, welcome to use it. Just have to enable macros to make it work. So now I have to close this out so we can load it in JASP and show you how to do it in JASP. So the assumptions: dependent variable is a continuous scale variable. Normally distributed, approximately normally distributed, no significant outliers, and the independents are going to be two matched categories of the same variable. So, usually you got a time 1 or time 2. Sometimes, sometimes you may have different months for just, for store, I don't know, different months for regions or something. You want to see the same region, perform differently for seasonality, or seasonality differs, across all of them. So let's go ahead and load that same matched paired t-test. So here we go, open a computer, and right here, and we'll click on paired T this time. So as it opens, okay, and you'll see here, so we've got pre and post, and you can go ahead, like I said, and click descriptives if you want, just to make sure you got no missing, nothing. We're expecting this to, left to be, the right to be a little bit lower because it is diet, but the standard deviation's higher. So is that really significant? That's what we want to know. The min and max seem to be the same for both. So somebody didn't do, unless those are different people. So let's go to t-test here and click paired sample. So now when you click this over and you go pre, it's going to set this up. SPSS does it the same way, and then you match post. So here you got our degrees of freedom, 77, because we had a sample size of 78, and this is all one sample, so that -1. So we need to check our normality. We're good. Now our location, that's going to be the difference between each item, or the mean, not the mean, the difference of the mean, or the mean of the differences here. Standard error of the difference. So this over this is obviously going to be fairly large. We've got a T of 13, so it's going to have a significant difference here. Put a confidence interval here. So we're confident we got between 3.4 and 4.3 pounds lost. Is that significant? Obviously it is. So what's the effect size on that? 1.4, very large. So, you can type your descriptives and your plots and your rain clouds, all of this. And what's it going to show here? There's your difference. You can see all of these are pretty much all of these are look like you're headed down maybe. This doesn't look like it's significantly different, but when you match those pairs, it only takes, you don't have to have both samples completely different. You got to have a little bit of difference with every line. So you do this, we didn't have any outliers. I mean, you'd want to include those list wise for this one, or it won't run if you had any. So let's see what all he put here. Everything I had except for he didn't have the rain cloud plots here because they're kind of messy, but actually I kind of like having them there because it shows you every line is just a little bit, and that's plenty enough to make it highly significant. When we were testing against 0, and we ended up getting from 3 to 4. And again, when we're talking about significance here, if you got a large sample size, even the tiniest of differences could be significant. You could have 0.1 at the bottom of that confidence interval. It's going to be significant as long as 0 is not in the middle of it. But you'd have a significant value for an effect that doesn't matter. I mean, who cares if you lost 0.1 pounds in 10 weeks? So that's where, you get p hacking, like, your discussions are talking about. You find ways to get significance of 0.05 just because that's kind of the academic standard, but it's just an arbitrary number made up. And I mean, what does P05 mean? 1 in 20 chance that you could be wrong, but even if you're right at 0.1, if that's your lowest, confidence level, is that a significant difference? It's statistically significant, but it's not useful for decision making. It's not practical. So that's why you kind of need, and p-value doesn't tell you the strength, the effect size tells you the strength, and so it's tied in with your power. So I showed you how to do all of those, how to fetch all of those numbers earlier if you want to determine power or play with your effect sizes. So now how do we write these up? Pure wilt is not significant, suggesting that the pairwise difference were normally distributed. Therefore, the assumption is not violated. And then you put your pure wilt, score here and p-value. Then post diet body mass was lower than at the start of the diet. So you got the mean standard deviations for both of those. The mean difference shown to be significant. So you get those from your mean standard error here, from your t-test score. And then you write the value of the test to show, how significant. And that's going to be T of 77. What did I just do? Okay, T of 77 equals, and that's your degrees of freedom, remember? Unless you get real fancy and actually use a sub, but this is fine. T of 77 equals 13.4. That's our t-test, comma, or that's our test statistic, comma, and the p-value. And then one last statement, Cohen's D of 148 suggests that this is a large effect. It's actually an extremely large effect. So if they weren't significant, we'd use a Wilcox rank. And this is the one, on the last one I told you, he kind of used different. So he used pre-anxiety and post-anxiety, but he's got he still got, the paired samples for this in there, and then he halves the biaxial rank for some reason. It's 0.92, but he put half of what we had up here, so I don't know. It's kind of got messed up. So for non-parametric distribution paired test, you'd use Wilcox and sign rake. If you really want to know how to do those, go look up my dissertation somewhere. I did a bunch of them. So other than that, let's just stick with the T and call it a day. So these are the three types of tests you're responsible for, all the assumptions, how to figure them out, how to determine which one to use for each one. So that should get it for this week in JASP. So thanks for stopping by, and I hope this helps.